In episode 8 of Chasing Dexter, we looked at how the vagus nerve plays a critical role in managing, among other things, chronic inflammation. In this episode, we're going to take another journey deep into the human body, diving into a biological mystery that is literally hiding right beneath our breastbones. For decades, the medical community just looked straight past it. They thought it was an organ whose importance faded after childhood, but it actually remains functionally important right throughout our lives. It's a mystery how doctors essentially ignored this organ for years, assuming it had just packed up and retired. But as we're going to discover those deep physiological shadows, that's exactly where some of the most profound secrets of human health have been hiding. As it turns out, this master regulator of our immune system might just force us to rethink absolutely everything we thought we knew about aging. So it brings up a really provocative question. Does a disappearing organ actually hold the secret to longevity? We're looking at a true biological enigma here, thanks to some incredible groundbreaking AI-driven research. Scientists are pulling this overlooked gland out of obscurity, and they're increasingly pointing to this very organ, one that naturally shrinks as you age, by the way, as a literal potential fountain of youth. I know it sounds like wishful thinking, but the data we're about to unpack is very, very real, and it completely challenges a decades-old assumption about how our immune system actually ages. I'm Alan Virtue, and this is Chasing Dexter. The organ we're talking about is the thymus. It's nestled right there in the upper chest, just in front of the heart. The ancient Greeks named it, and the word is linked to the Greek thymos, meaning spirit or soul-like vitality. Scientifically speaking, though, its role in early life is nothing short of miraculous. The thymus acts like a biological factory through your immune system. Specifically, it's where T lymphocytes, or T cells, travel from your bone marrow in order to mature and essentially be educated for adaptive immunity. It literally trains these white blood cells to hunt down infected or cancerous cells and coordinate your body's entire immune response. In newborns, it's large, robust, and highly active. But then something strange happens. It's called involution. And right now, inside your own chest, this mechanic of the immune aging is quietly taking place. We used to think that the thymus simply shut down, that it just became completely inactive after childhood. But actually, it doesn't disappear completely. Instead, that highly functional tissue that trains your T cells is progressively replaced by fat and connective tissue. And what's truly surprising is just how early this begins. It starts during childhood and then really accelerates right around puberty. As it shrinks, its capacity to turn out those essential brand new T cells gradually but definitively declines. The contrast here is just stark. If you picture the vibrant, robust thymus of youth, rich, highly textured, functional tissue churning out a diverse army of T cells ready to fight off a massive array of threats, but then look at the aging adult thymus. It's smaller, it's overrun by fat, and crucially, its structure is progressively disorganized. Researchers at WEHI, the Walter and Eliza Hall Institute of Medical Research in Melbourne, recently made a world-first discovery about this, finding that age-related changes in the thymus compromise its function and limit responses to new infections. Professor Daniel Gray, who's division head at WEHI, put it absolutely perfectly. He said,
So not only is it shrinking, but the light's dimming as well. You're more likely to encounter infections you've had in the past, but it can become a problem when new infections arise.
So not only is it shrinking, but the light is dimming as well. Now think about that for a second. As that thymic activity declines, fading into those deep shadows we talked about earlier, the diversity of your T cell population becomes severely limited. You know, you might be feeling totally fine encountering infections you thought of in the past, but when a completely new infection pops up, your aging immune system really struggles to adapt. That light dimming means you have a much slower capacity to rebuild your immunity, exactly when you need it most. But how in the world do we measure that dimming light on a massive scale? Well, we turn to artificial intelligence. This is where the story takes a huge leap forward. A groundbreaking study led by Hugo Ertz and his team at Harvard Medical School and Mass General Brigham redefined how we view this organ. They deployed a deep learning AI model to analyse over 27,000 routine CT scans from adults. By pulling these massive data sets from the National Lung Screening Trial and the Framingham Heart Study, the AI analysed the thymus to generate a thymic health score. Now, what's really interesting about this graphic is the reality hidden inside those AI health scores. It is just staggering. When the Harvard team looked at the data, they discovered that adults who maintained the high thymic health score had a 50% lower risk of premature death compared to those with low thymic health. 50%. And this wasn't some small margin of error. This association remained rock solid even after the researchers adjusted for age and other underlying health factors. The physical state of the shrinking gland was directly tied to human longevity. In this connection, it extends way beyond just general mortality. When researchers isolated cardiovascular disease, which, by the way, is the leading cause of death globally, they recorded a shocking 63% lower risk of cardiovascular death for adults with a healthy-looking thymus. 63%. It strongly suggests that thymic health isn't just about fighting off a common cold. It might actually reflect our body's overall systemic resilience against the most complex age-related diseases we face as human beings. And the implications even reach into oncology. The AI analysis found a 36% lower risk of developing lung cancer in those with high thymic health scores. When T-cell diversity declines because the thymus is failing, the immune system simply becomes less able to respond to those insidious microscopic cellular threats that eventually develop into full-blown cancer. The thymus, it turns out, is a master dictator of our adult immune resilience. If you need a slightly grim contrast to prove just how absolutely vital this organ remains well into adulthood, look at the pivotal 2023 study. Researchers looked at adults who actually had their thymus surgically removed. The results were stark. Compared to the general population, those without a thymus were 3 times more likely to die and twice as likely to develop cancer within just 5 years of the removal. It completely shatters the old medical dogma that this organ just outlives its usefulness after puberty. There is no way we can ignore it anymore. This critical importance extends directly into modern cancer treatments too. In a separate study published alongside that Harvard AI research, scientists analysed CT scans and outcomes for over 1,200 patients undergoing immunotherapy. The data revealed that patients with stronger thymic health had a 44% lower risk of death than those with poorer thymic health. It turns out this totally overlooked organ might just be the missing puzzle piece in understanding why cutting-edge cancer treatments fail in some patients but succeed brilliantly in others. So naturally, a big question arises. What causes the thymus to degrade faster in some of us? Well, the Harvard AI analysis connected the science right back to our daily lives. They identified lifestyle factors associated with thymic decline and reduced thymic health, including smoking, high body weight, and features of metabolic syndrome, such as high blood pressure and elevated blood sugar. Essentially, chronic systemic inflammation acts as a massive accelerator for immune aging. The way we live our lives directly impacts the architectural integrity of this vital organ. And this brilliantly illustrates the next massive frontier of medical science, the race to regenerate the thymus. We're officially moving from observation to action. First, as we learn from thymus regeneration research, scientists have identified age-related epithelial defects that limit thymic function and regeneration, which may help guide drug development. Secondly, biotech companies are exploring therapies aimed at restoring thymus function, including approaches that target thymic epithelial cells and related regeneration pathways. And third, clinical trials are already underway for thymus regeneration, including the primary clinical trial evaluating human thymus regeneration, sponsored by Californian biopharmaceutical company Intervene Immune. The Thymus Regeneration, Immunorestoration and Insulin Mitigation Extension, or TRIMEX as it's known, is a 12-month trial using 40 to 80-year-old participants with a goal to rebuild functional thymic tissue, boost naive T-cell output, and evaluate markers of epigenetic age reversal. Which brings us right to the edge of the unknown. We're looking at a future where we might actually tap into the body's own fountain of youth by simply restoring the light to an organ we once thought was entirely useless. The biological evidence is mounting. If we can successfully halt the shrinkage of the thymus and restore that robust youthful T-cell production, how much longer and how much healthier could we thrive? And as this incredible science moves out of the shadows of the lab and into the real world, who should be the first to receive this life-extending treatment? It's really a profound question to leave you with, but I think it's important to note that if these regenerating therapies actually work, they won't just be handed out to healthy biohackers looking to slow aging. The very first recipients will undoubtedly feed the sickest patients, those with the highest unmet medical needs, where the benefits clearly outweigh the risks. Okay, so you're sold on the power of the thymus gland, and now you want to know, well, how do I actually check if mine is healthy for my age? Can you just walk into a clinic and ask for a thymus score? Well, yes and no. Right now, tracking your thymic health falls into 3 distinct tiers: the cutting-edge science, the practical tests you can get from your doctor today, and the functional markers used by longevity experts. Let's break down exactly what you can and can't do. First up, Tier 1, the cutting edge. As we've discussed, right now, medical researchers are using advanced deep learning AI to analyse routine chest CT scans. They use this data to calculate a precise thymic age or health score compared to other people of your age. But here's the catch. You can't just go and order this. It's currently confined to clinical research trials and specialised longevity institutions. It's the future, but it's not something you can get at a standard walk-in imaging centre today. So what can you do right now? Well, that brings us to Tier 2, the practical pathway. If you want to check your thymus today, you have to look for indirect clues. Here is what you can actually ask your primary care doctor for. First, check your medical history. Have you ever had a chest CT scan or a chest MRI for something else, like a chronic cough, a sports injury, or a heart check? If so, a radiologist has already looked at your thymus. Ask your doctor to pull up the report and look for phrases like normal thymic involution for age or residual thymic tissue. That tells you if things are tracking normally. Secondly, ask for a standard complete blood count with differential. This basic blood test measures your total lymphocytes, which are your white blood cells. While it doesn't give you a direct thymus score, standard healthy ranges mean your immune baseline is solid. And third, monitor your metabolic panel and inflammatory markers. Rapid thymus shrinkage is heavily accelerated by poor metabolic health and chronic inflammation. Tracking your HbA1c for blood sugar, your triglycerides, and a marker called hsCRP for systemic inflammation gives you a clear picture of the environment your thymus is living in. Keep these optimal and you protect your thymus. And finally, Tier 3, advanced functional testing. If you're working with a longevity physician or an immunologist and are willing to pay out of pocket, there is a test that directly measures thymic output. It's called a TREC test, which stands for T-cell receptor excision circles. Think of TRECs like the biological wrapping paper left over when your thymus manufactures a brand new untrained T-cell. When the thymus creates a new cell, these circular DNA fragments are left behind in your blood. High TREC levels mean your thymus is actively churning out fresh immune soldiers. Fewer TRECs means it's slowing down, indicating a reduction in thymic function, a biological process called immunosenescence. A TREC test is the closest thing we have to a direct molecular checkup from adults. Now, a quick tip before you rush out to your doctor. Do not ask for a chest CT scan just to check your thymus. Doctors will not order one without a strict medical necessity because of the radiation exposure and the high out-of-pocket costs. Instead, use your energy where it matters most. Lifestyle. Focus on maintaining a healthy weight, exercising consistently, and avoiding smoking, all of which have been proven to slow down the thymus aging. Your lifestyle is the best tool you have to keep your immune system young. Thank you so much for joining me on this episode of Chasing Dexter. I hope it's left you as completely fascinated as I am by the evolution, probably revolution is a better word, happening in the world of aging and longevity research. Please like and subscribe to learn more about the current state of age-related research, along with the actual stories of those who are living or who have lived long, healthy and extraordinary lives. I'll be back soon with another episode of Chasing Dexter. Bye for now.